Was Opus 4.6 the only upgrade from Anthropic? You already know about sub-agents, where each agent operates as an individual entity with its own context window. But these sub-agents failed when there was a task that required coordination between them. In those cases, the orchestrator had to step in, taking responses from one agent and delegating them to another, or the agents had to rely on notes in the project folder. Because of this communication gap, simple tasks would become too overcomplicated. To deal with this, Anthropic released a new upgrade to sub-agents and named them agent teams. They've been launched alongside Opus 4.6. Although this is still an experimental feature, we've implemented it in multiple workflows, and the greatest improvement was that the time these tasks took was greatly reduced. But it is experimental for a reason and still has some rough edges, and we found little fixes for those problems as well. Agent teams is the idea of having multiple Claude Code instances working together. Each member of the team works on isolated tasks and has centralized management controlled by one agent. Now, you might think this sounds really similar to the already existing Claude subagents because both run in parallel and split up tasks, but they're not the same. This is because agent teams solve the one problem the sub-agent framework has. Sub-agents are not able to communicate with each other and have to rely on the orchestrator agent to act as a medium of communication for them. Team members, on the other hand, are able to communicate with each other. The core idea behind agent teams is having multiple Claude Code sessions working together. One session acts as a team leader, coordinating work, assigning tasks, and synthesizing results, while the teammates work independently in their own context windows. Sub-agents have their own context window, and they report the result back to the caller. But for teams, it works differently. Each member of the agent team is a fully independent terminal session. They're not restricted or coordinated by an orchestrator that just divides tasks. Instead, these terminal sessions are opened and closed by the main team lead. They are able to work across tasks that require discussion and collaboration between agents because of their ability to communicate. So an agent team essentially consists of a team lead and teammates. The team lead is the main agent that creates the team and coordinates their work. The teammates are the workers who actually perform the tasks. Each teammate receives a task list, which is a shared list of items. Each member identifies what it needs to do from this list and executes it. To communicate, they also have a shared mailbox that allows them to send messages to each other. Now, the question was how this actually works if each team member is independent. How do they know what the other members are doing? This works because all the information regarding the team, the members, and the tasks each member is working on is stored locally in the .claude folder and identified by the task name. This feature is still experimental and disabled by default, so there are going to be some bugs in teammate handling during this phase. In order to try it out, we had to manually enable it. We did this by setting the Claude Code CLI flag for experimental agent teams to 1. With this CLI flag enabled, agent teams were available for use in further sessions. With this flag enabled, we were able to access the Teams feature in Claude Code. Since this is an experimental feature, we needed to use specific wording that tells Claude we want to use the agent team for a certain job. Our team has started using this feature to parallelize code review, letting code issues be identified and fixed at the same time. To do this, we asked Claude to use one team member to find issues in the code base and another to fix the issues identified by the first member. We had to be detailed in the prompt to make it follow the right direction. Now, if sub-agents were handling this, they would be writing a report to some physical file to let the other agents know what to fix. But here we wanted to speed up the review process by letting this happen without the overhead of writing to a local file. When we gave the prompt to Claude Code, the team members spawned, each controlled by the team lead. The lead agent gave the prompt to individual agents, letting them know what task to perform. Now the first code reviewer agent started working, and after analyzing the task, it shared messages with the code fixer, bug by bug. This agent was prioritizing critical security issues, and once the code fixer received the messages from the code reviewer, it started implementing the fixes while the code reviewer continued looking for more issues. Similarly, they kept talking to each other and reporting back the changes that were implemented. Once the critical issues were completed, the two agents moved towards fixing the medium priority issues. The code review and code fixing were happening simultaneously, which saved a lot of time. The good thing about this is that you can also assign or modify any task for a team member. With this enabled, you can steer the direction of the work of that specific team member. Once the agents were done working, control was handed back to the main agent, which is responsible for making sure the required changes are implemented correctly and for shutting these agents down gracefully, ensuring their exit does not cause errors later on. You've probably noticed we build a lot in these videos. All the prompts, the code, the templates, the stuff you'd normally have to pause and copy from the screen, it's all in our community. This video and every video before it too. Links in the description. Parallel finding and fixing is a really good thing, but there are often cases where you get issues and just can't figure out what's causing them. In those cases, we can use an agent team to test multiple perspectives of the same app and work progressively toward the bug. This way, team members can communicate their findings to each other and move forward together. We asked Claude to find a bug in the code base and specified using multiple team members, letting them approach the problem from different perspectives. It then spawned 4 sub-agents, each focused on a different perspective of the same app. They received similar prompts from the team lead and investigated the errors based on their specific aspect of the application, while the main lead waited for them to finish and then analyzed the findings from their research. Without teams, we would have had a single thread, which would have taken much longer. But with these agents, the process was much faster. The investigation completed quickly, and all of the research by the agents was done in approximately 2 to 3 minutes, which is a significant improvement compared to linear checking, which would have easily taken 5 to 10 minutes. One thing to watch out for is that this approach burns a lot of tokens because each agent has its own context window, so we need to be careful about that. Once the agents returned their output and were shut down, the team lead also verified the results by checking itself. All 4 agents converged on the same bug, and they correctly pointed out the issue with a stale closure in the use effect. This exact part was flagged by all 4 agents. Also, if you are enjoying our content, consider pressing the hype button because it helps us create more content like this and reach out to more people. This agent framework has changed how we work on long horizon tasks because with their abilities, agents don't have to rely on documenting their progress only. With agent teams, we can handle different aspects of an application in parallel and also have a member dedicated to handling research. When we gave Claude the prompt, it spawned 6 agents. 2 were working on research and laying the foundations, while the rest were for building the pages. The builder agents were blocked by the agent laying the foundation because it was responsible for installing required packages and making the environment ready with all the dependencies. Each agent received a specific prompt defining their job. The blocked agents kept waiting for the unblocked signal from the team lead. Once the research and foundations were complete, the remaining agents were unblocked and started implementing their respective parts of the application side by side. They kept communicating with each other for consistency between each component. The team lead kept coordinating with the agents, and once any agent finished, the team lead sent a shutdown message to that agent, handling its exit gracefully. This whole process consumed around 170K tokens of the context window, but in the end, we got the app built exactly as we wanted, all from a single prompt. As we mentioned in the video, when our team was testing this, we came across multiple ways to make agent teams work better for us. And again, these best practices are available in AI Labs Pro, so you can try them out for yourself. The first recommendation is generally applicable to all agents and not only limited to the agent team feature. You need to explicitly specify the scope of where the agent should be working. You can do this either by defining it in the prompt, specifying which files to look for in order to perform the task, or by creating documents in the project containing individual tasks, as we did for our workflow, where we prepared a proper task document for each assignment so that the agent can work independently and within the right scope. Another thing to keep in mind is that each of these agents should be working on independent tasks from each other, because if they are editing the same file at the same time, it would create a conflict and might lead to overwriting the content. Aside from this, there were times when we found that the main agent would get impatient if any agent takes a long time to complete a task and start implementing the task itself instead of letting teammates complete it. So it's important to remind the main agent to wait for teammates to complete before proceeding. You also need to size tasks properly. If you assign tasks that are too small, it creates coordination overhead. If tasks are too large, it increases the risk of wasted effort. So tasks need to be balanced and self-contained. Finally, you need to monitor the agent's work. If any agent is not performing as expected, you can halt its execution and give it new instructions on what it should be doing. Following these practices makes using this experimental feature much more effective. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.